Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is a very interesting topic, that is trans fat or fatty acid. Why it is more dangerous than its cis isomer. So we'll discuss mainly from the basic understanding and chemistry perspective. But before going to the details, one MCQ for you: which of the following process closely resembles to saffinification or soap preparation? I request everyone, please pause the video, try by yourself, and whatever your answer, please write in the comment box along with few words as explanation. Don't worry, at the end of this discussion you will have the right answer. Now, before going to the details, let's look at what is the today's content, what point you're going to discuss on today's topic. First of all, the chemical reactivity, cis versus trans alkene. Next, importance of hydrogenation of oil. Finally, catalytic hydrogenation of unsaturated fat and the health hazard associated with it. And finally, its solution. And obviously, at the end, we'll discuss the MCQ. Now let's go to the first point. What is mean by cis and trans alkene? If you look at alkene means there should be a pi bond or carbon-carbon double bond. If the two same functional group on the same side, for example, these two hydrogens, same side. So that's why they'll call it as cis alkene or cis isomer. Now you may say, sir, R1 and R2, they are not same. It may be same, it may not be same, doesn't matter. We can conclude based on this hydrogen atom or same atom. In this case, these atoms are opposite same atoms, so that's why it will called as trans. Now just consider that these R1, R2 both are methyl group. Okay, so obviously if I say methyl, then what is the hybridization of this methyl? It is sp3 hybridization. What is the hybridization of this alkene? It is sp2 hybridization. We know that sp3 carbon has lesser electronegativity compared to sp2, so that's why this carbon will be delta negative, this carbon will be delta positive, because obviously this carbon is slightly more electronegative. I believe, actually I agree that this is a very less charge separation, but still it exists. So there will be a dipole moment, works in this direction, in this case also similar, this direction. And since dipole moment is a vector quantity, both of the dipole moment is working opposite direction, so the resultant dipole moment is 0. So you can say trans alkene is non-polar. Whereas if you look at the cis case, this is one dipole moment, this is another dipole moment, there is a neat dipole moment, this resultant mu is not equal to 0, so it's a non-polar. By the way, the polarity is very less, the dipole moment value is very small, but still I can conclude it's a non-polar. And since there is a particular orientation of dipole moment, means electron density, so I can conclude this is comparatively more reactive. So what I am talking electronically. Now if you think sterically, this side both are hydrogen, smallest atom, less bulky, so the reacting molecule can approach from this direction more efficiently. So both sterically and electronically, cis isomer is comparatively more reactive than trans isomer. Okay, and this reactivity creates a lots of difference, which we'll discuss later on. Now this part we understand cis and trans alkene. So if this kind of bond present, it can cause difference in property. Now before going to that, let's look at why the hydrogenation of fat is important. Okay, if you look at cooking oil is actually liquid at room temperature. Why? Because in cooking oil there are lots of unsaturation, carbon-carbon double bond, carbon-carbon single bond, and carbon hydrogen bond. Whereas if you look at animal fat, it is solid at room temperature because it has only CC single bond and CH single bond. There is no double bond present. So that's why you may consider, okay, saturated straight chain, so the van der Waals force of attraction among these straight chains are more, so obviously that causes the higher boiling point or melting point. Actually, since they are solid at room temperature, more accurately if I say, it is actually waxy solid, so if you heat it, it melts. So it's solid at room temperature because higher van der Waals force of interaction. Next, it's a prone to chemical reaction. Why? If you look at CH versus this carbon-carbon single bond, these two are sigma bond, and sigma bond is chemically less reactive than this pi bond, because pi bond is made of parallel or sidewise overlap of the p orbital, and the electron density involved in the pi bond formation are weakly attracted by both of the nucleus. So consequently, these loosely bound electron density resulted higher reactivity or prone to chemical reaction, means degradation, biological perspective if I think. In this case, there is actually carbon-carbon single bond and carbon hydrogen single bond, so that's why it is comparatively less prone to chemical reaction. So you can say more stable. So that's why the product made of such kind of saturated fat has higher shelf life, means you can store for longer days without proper degradation. But here it's a lesser shelf life. Why? Because this pi bond react. Okay, so it get denatured very earlier. Now if you look at this plant oil, they are cost effective. Why? Because plants are producing, and it's climate friendly, because plant preparation of oil is a product of photosynthesis, so overall you are consuming carbon dioxide. But if you look at animal fat, it's costlier and animal cruelty involved, and it is not that much friendly for climate. Why? Because when you graze animal, for example cows or buffaloes, so during its lifetime it consumes huge amount of water, point number one. Second point, it emits huge amount of methane and carbon dioxide, so both are greenhouse gas. So from that perspective it is also not good. So this is the thing. Now as a question, why we consume animal fat then? Because it tastes good. Now it's costlier, climate impact is there, but it tastes good, that's why we want. But isn't it possible that we can convert these oil or these unsaturated fat into saturated fat? Because previously we have studied that this process could be achieved by catalytic hydrogenation. Which catalyst? Catalyst could be nickel, could be palladium, could be platinum, and among three nickel is the cheapest, so that's why it's preferred. Now in presence of catalytic amount of nickel and high pressure hydrogen gas, so what you can do, you can do hydrogenation, or you can achieve hydrogenation on these bonds, double bonds, pi bonds, because they are more reactive. Okay, and under this condition this ester doesn't break, so don't worry. So here this hydrogenation causes, now you may say, okay sir, there were two bonds, one is hydrogenated, there was one bond, it is not. So you may say this is a product of partial hydrogenation. Look at the next one. So everything is same, but here there is a story. If you look at this, is a cis, these both are cis double bond, it is trans double bond. Just sometime before I told that cis is chemically more reactive, trans is not. So this is the main problem. During this catalytic hydrogenation, this trans is produced. Why? Remember, trans alkene is more stable. So that is the reason. I'll discuss it later on. Now in this case we get, now you may ask one question, sir, can't we achieve complete hydrogenation? You take excess of this hydrogen, prolong reaction time. Isn't it possible? Technically possible. You can have complete hydrogenation, but the problem will be there because you may not have a particular taste for some kind of fruit, for example crunchiness, some other behavior. That's why we don't use completely hydrogenated product. Okay, I guess everyone will agree that sometimes taste matters more than health. Okay, so that is the story here. Now next, what is the problem? What is the health hazard of it? Actually it increases the LDL or low density lipoprotein or bad cholesterol, and it reduces these HDL or good cholesterol. So what it result? Cardiovascular diseases, means artery fat deposition, or another thing, tummy fat like abdominal fat. So what happened in this case, you have a artery here, and here these fats are deposited. Now you may ask one question, that sir, why the fat will deposit here? Now if you look at student, you have a cis part, so cis, this chain has a abnormality or breakage here. Okay, so you may expect, okay sir, this is because of this cis double bond, this chain was like this, suddenly cis, suddenly this. So the packing or interaction of these alkene, means hydrocarbon chains, are not that much good in case of cis. Whereas if you look at in trans, means okay, this is trans, this is another case trans, this is, so their interaction is more, so proper interaction, proper overlap is more, so that's why you may expect the melting point is more in case of trans. So that's why if you look at this trans fat, they are actually solid compared to the cis one. So if they are solid, they get deposited more easily. So I guess you understand why this trans fat is the culprit. Both are carbon-carbon double bond, but this trans get this deposit more efficiently compared to say, because of their interaction, symmetrical structure. That's the reason. And it can also increase the type 2 diabetes. Okay, and if you have more amount of this trans fat deposited within the artery, so it can cause any blockade. So this is a big problem, means health hazard for this trans fat. Now What are the solution here? First of all, public awareness means whatever thing you are purchasing, there must be proper label how much trans fat is present here, what is its health hazard, etc. So people will be aware, because if you know whatever you are consuming it is not that much good, so you'll try to consume it less. That's a good thing for you. And for that purpose there must be strict law country wise. I guess there are such kind of law exist in developed countries, but for developing countries we need to do more. Next, it's a very important point. Multiple use of same cooking oil increases the trans fat content. Question why? If you look at, this is a cis alkene, this is a trans alkene. If you change this RR part, so you can make this is a cis fat, this is a trans fat. I have shown the image previously. So you can say that trans is more stable, okay, compared to cis. So if you heat this oil means fat for longer time, means high temperature heating, for example multiple frying, you are using this oil, so what is expected? Slowly these C's will be converted to trans. Why? Because it's more stable. So you can say it's a thermodynamically controlled product, or TCP. So multiple heating also increases the percentage of trans fat within a particular cooking oil. So obviously, so if I say you are consuming oil multiple times, means you are making it more poisonous. Other factor will be there, but I'm not going on that. I'm saying if you follow everything properly, but during this frying, heating, some amount of C's will be converted to trans, and that can cause the health hazard. So very careful, do not consume same cooking oil for multiple times. And the final thing, eating should be designed based on your calorie requirement, what kind of work you are doing. If you are doing a sedentary lifestyle, you should consume less calorie, less fat. So obviously there will be a calorie balance that can help you to maintain a healthy life. Okay, so let's go to the MCQ. Now, which of the following process closely resembles to saponification of soap preparation? By the way, students, soap preparation is actually ester hydrolysis. So these two are wrong. So it's a ester hydrolysis in presence of aqueous sodium hydroxide. Okay, sometime you can use potassium hydroxide also, that will work. So what happens here, this actually it's a triglyceride ester. Why? Because this part, if you look at, it produces, this is glycerol. Okay, so this is 1 2 3 propantriol. So this is glycerol, and this part, this R is, remember student, long chain. I'm talking this R1, R2, R3. I've shown previously one photo, you may go there. So this is a long chain. So these hydrolysis produces, these are the salt, and this is the alcohol, glycerol. So this part, this salt, this is called soap. Okay, so this saponification of soap preparation is catalyzed by aqueous sodium hydroxide in presence of heating. Heating is needed for this purpose. So option D is your right answer. So this is the overall discussion. I believe this video may be useful, but remember one point: if we can't control our desire, we have to suffer physically and mentally. Very important point, student, remember, it will help you a lot. So thanks for watching. If you are watching from YouTube, please like, share and comment this video and subscribe this channel. And if you are watching in the Facebook, so please like the page and share among your friends. So see you in my next video. Bye bye.